All right, so at this point, we should be really good at multiplying polynomials together. Now what we're going to do is multiply polynomials to polynomials, and we're going to look at a special case, which is multiplying a difference of squares. So at this point, we have multiplied binomials to polynomials. Now what we're going to do is multiply trinomials by trinomials. So we have to actually just add one more line. So we're still going to do that distributive method. So we're going to take the first to the first to the middle, and first to last. And that's going to give me 2n to the fourth plus 6n cubed minus 12n squared. And then we're going to do the same thing, but now we're going to do it with the middle term to the first term, the middle term, and the last term. And that gives you negative 2n cubed minus 6n squared minus 12n. And actually that's a positive 12n. Okay, now we're going to do it one more time. We're going to take positive 2 and multiply it to the first, middle, and last. So that gives you 2n squared plus 6n minus 12. And then we're going to add these terms together. So you get 2n to the fourth, 4n cubed, negative 18 plus 2 is negative 16, positive 12 and positive 6 is 18, and negative 12. So difference of squares is a formula we talked about in the quadratics unit. And basically what it says is that you have the same beginning and end of your binomials being multiplied together. So x plus y times quantity x minus y will always give you the middle terms canceling each other. They will always be the same. So we can generalize this to say that x plus y times x minus y will always be x squared minus y squared. So we have that formula represented down here with the a's. But again, all it means is that the middle terms will always cancel if the two binomials are the same, with one being positive and the other negative. The reason I bring this up is because when we are multiplying and we have this, if the numbers we're multiplying are a little bit more complicated, then this little trick helps us get through them faster. So for example, 3 plus 5x to the fourth times 3 minus 5x to the fourth, using our special formula of a squared minus b squared, says that this is the same as 3 squared minus quantity 5x to the fourth squared, which is really just 9 minus 25x to the eighth. Because again, that squared term here distributes to the 5 and the x to the fourth, and a power to a power is multiplied. Let's look at one more using that special formula for difference of squares. 9c squared plus 6c to the sixth times 9c squared minus c to the sixth gives you 9c squared squared minus c to the sixth squared. So again, that squared is going to go to the 9 and the c squared, becoming 9 squared c 2 times 2 minus 6 times 2 for the second term, giving you 81 c to the 4th minus c to the 12th. Once again, head on over to Khan Academy and look at the problems involving that special case, and then you're going to complete the quiz and unit test. Good luck!